So I'm going to talk about the first derivative test today. The first derivative test can be used to find like critical points, the maxes and mins, and what you have to do first of all is you have to make sure that it's continuous, that the function is continuous on the interval, on the closed interval. So f is continuous on the closed interval. And then what you also have to do is make sure that it is differentiable. So the function is differentiable on the open interval. And then once it's good, you find the first derivative of the function. So what I'm going to use f of x is equal to negative 2x squared plus 4x plus 3. So to find the derivative, just find the derivative. So 2 times 2 is 4, negative 4x plus 4. That is our first derivative. So when you find the first derivative, you set it equal to 0 to find the critical points. Okay? So f of x equals negative 4x plus 4, which is equal to 0, which would be, you subtract 4 divided by negative 4, x is equal to 1. So this is our critical point. So to find our max and min, what I do is I make a little timeline, put my 1 there, and then you do test points. So I'm going to use 0. So what you do is you take 0 and you'll plug it back in to the derivative. So at 0, we'll have a positive number, right? Because 0 times negative 4 is 0 plus 4 is 4, which is a positive number. And then let's use 2. So if we use 2, right, we'd have negative 4 times 2 is negative 8 plus 4 is a negative number. So we'd have a negative number. So when we do this, we are going to plug 1, our critical point, back into the original function to find our maximum or our minimum. In our case, this is a maximum point because it goes from positive to negative. So we're going to take 1 and plug it back into the function. So f of 1 is equal to negative 2 times 1 squared plus 4 times 1 plus 3, which would equal to negative 2 plus 4, which is 2, plus 3, which is 5. So our point is 1, 5. That is our maximum point. So now we can take that and we can use that. So we can say from negative infinity to 1, we have positive values. So we could say that it's increasing on negative infinity to 1, and that it's decreasing on 1 to infinity. And what we also do know is that the relative maximum, I may have spelled relative wrong, it doesn't have an A there, relative maximum is 1, 5. So you see you can use the first derivative to find the critical points, which you set the first derivative equal to 0, and then you use that, you can use that as a critical point to find the positive values, the negative values, see where your max and mins are. So whenever you have a max, it goes from positive to negative. Whenever you have a minimum, a relative minimum, it goes from negative to positive. I hope this helps you. Thank you for listening.